Hello everyone, I'm going to do another draft of lecture 6c, hopefully not so laggy this time around. So let's get going to what I wanted to actually look at. We're going to be making, I'm just going to open up one of my most recent project. Here we go, linked list, inherit. We're looking at inheritance for linked list. I've done this demo before. I've had to re-record and re-record all these things in various parts. So fun times. What we're talking about this time is we're looking at our linked list again, but I'm going to make a child class. Instead of a normal linked list where I go from one node points to the next node, points to the next one, next points to the next, I'm also going to point the other way around, backwards. So this points to this, and also this points to this. I have a previous, every node will have a previous and a next. I'll also have a start and an end to my linked list. So what I want here, here's my normal linked list. Here's what I have inside of it. Oh, I have a start point. That's it. That's all I have. That's my normal linked list. My new linked list will have a start. It will also have an end. And when I want to, I can add to the start or I can add to the end of my linked list as a result. The point of all of this, notice, let me look at a couple of these parts to it. I have a series of public functions. Remember, when we have a public function, it means everyone can see it. Everyone can use it. Everyone can use the plus operator for a linked list. Everyone can insert a data item. This is just data, some kind of stuff that I'm storing on my linked list. I can add data to my linked list. I can remove data from my linked list. I can just remove the front element. I can just remove the back element. If there's no element to remove, there's no element at the front or the back, nothing happens, I return false. As in, nothing happened. If I remove something successfully, I return true. Hey, that first element was removed. Do I know how things are stored in my linked list? No. That's the point. I want this to be, I don't want you to know that it is a linked list. I can call it a linked list, but I don't want you to have to know how it's implemented. Technically, I can implement a linked list with an array without these pointers, just an array, and just happen to know what the next element is. You can be blissfully unaware of how this thing is actually built. You shouldn't have to know how your car is built in order to drive it. I just want a car that drives. I want it to work. I don't want it catching fire. I want it to have certain standards, some certain guarantees about it. But I do not want to know exactly what kind of engine it is and how it works and blah, blah, blah. As I said in my previous version of the video, I don't want to know how the sausage is made. I just want to eat it. So here is, I have a function I can insert things at the front, insert things at the end, right? And I know I have some order, I have a list. I don't want to know that I have a bunch of pointers and stuff. Here are two new functions that I've added. They weren't in there before. I can get, the fourth element, get the sixth element. How? Don't know. Just get me the sixth element. And I can get the size, how many items are on my list. That seems kind of useful. I can see if it's empty. It's related to finding out the size. And the only reason I have these two functions right here, the real reason I have these two functions is because I don't want to touch them. What we're showing is inheritance. And I'm going to show you that I get those functions for free. From when I make a child class, it automatically gets these functions. If I don't override it, I'm going to use the default way of getting these. Get index is going to work the same for the parent class as for the child class. Checking to see if something is empty and printing something out. I might want to override this one. I don't think I even need to override this one. If it's empty, it's empty. Do I have a starting point? Okay. Here we go. I have a couple protected methods, meaning I know about this function. So the class knows about this function. If I have another linked list class, it knows about this function as well. And child classes know about this. Notice this is getting the start node, and it gives me a node, but I don't want other people to know that I have a whole bunch of nodes inside of a linked list. It should just be some magic container. Call it Susan, call it Super Link 5000, whatever the case is. Throw whatever you want in this. It just stores data. How? Don't know. Don't care. That's the point. Whether I can insert, and I've also added 2 new functions in here. Inserting something at the front, but I pass in the node itself, not just the data, but the node itself, because that's going to help me with my coding. It is just another step. It'll also show polymorphism, which we'll get to soon. It is allowing me to insert at the front with the particular node that I'm making, and it allows me to, it's going to help me design my code. Okay, and then I also, since I don't have access to these private variable, I need some way of setting the start position. That's where set start pointer comes in. That's why I need that, because this is private. If I made this protected, the child class could modify it, but maybe I don't want that. Maybe I want to make sure that I have some sanity checks, that you cannot add, you have to make sure that it's a linked list node of a particular type, for example. Okay. That's all we're doing so far. I want to double check the video here. Oh, it's actually recording, at least I'm hoping. Here's what we're going to do. We're going to make a brand new class. In fact, I've already done all of this, and then I had to remove my linked list class again. So you'll see that I have dllnode.cpp, dllnode.h. This is what I'm going to do in later videos. I just left them in there. I also made a brand new thing just to show you another technique. If these include header files gets really out of hand, one thing you can do is for each and every time I say, let's say, for each one of my CPP files, I could have include this generic header file. Every single one including the same thing. And you'd say, why would we do that? Because this generic header file has all my other includes and then using standard namespace. This is the stuff, so this way by having all my CPP files point to this same header file, the first CPP file to be compiled includes all the header files, and I make sure that all my CPP files all have access to the same information. I control, this is just one technique in case header files get out of hand for you. This is one technique to make sure that I know that I'm going to include IOStream first, then I'm going to assume include my assert.h in there, then linked list node, then linked list node, then linked list, then doubly linked list node. Right? That particular order. Okay, let's make a class. So all that to say, this is just one way of keeping the complexity under control. If every single CPP file includes that thing, then I don't have to worry about weird ordering effects. It's always going to go in that particular order. Let's do this. So I'm going to make a brand new class. New class, and doubly, hopefully, oh, my keyboard is unplugged. Linked list. All right, and the base class is linked list. All right, hopefully that's fine. So this is the class I'm going to extend from. This is my brand new class. The name of this we're not going to change at all, ever, the entire rest of the term. It does mean something, but it just means if it was private before, it's still private now. If it's protected before, it's protected now. I'm not reducing the visibility of particular functions. Okay, I'm going to press OK. That seems to be everything's fine. Okay, let's have a look. Okay, yeah, that'll do. I'm going to make a D-linked list, and then I don't think I have anything for my D-linked list. So here's my constructor. I want to make sure it's the right constructor. Okay, I may have to change this one around actually, because I need to include, where's the LL data defined? I need to figure out where that's defined. Okay, so here's my constructor. my actual doubly linked list node is right here. That's this one. Okay. I'm going to call the parents version of it. This is a child class, so the parents constructor gets called first. I'm going to call the default constructor. I can actually leave that off. It doesn't make any difference whatsoever. I want to double check what my constructor looks like. Okay, it's a blank constructor for the parent. Great. It's the only option I have. I can also add destructors if I wanted to. But the reason I'm doing this, the only reason I'm doing this, let's see where my... that's fine. Okay. I'm just seeing if there's something else I'm missing because I have a bunch of errors here. Where is that defined? LL data is defined somewhere. I think it's in LL node. Oh yeah, it's in LL node. All right. So the easiest thing to do would be, oh, dang. And that'll do it. Hopefully. We're going to find out. Okay, everything compiled. Let's run it, see what happens. And nothing changed. It's exactly what it was before. And you'd think, well, that's because you didn't do anything. This doubly linked list node, you know, I don't make any doubly linked list nodes, so that's the reason why it's all going fine, right? If you were smart, you would actually change it from a doubly linked list, from a linked list node to a doubly linked list node, and show that this thing is going to break. Okay, sure. D. I need to figure out if that's going to work. Oh, why is that not working? Because I need to change this include file. Oh, we have something wrong here. Private access. And, oh, haha, there we go. Little minor mistake. There we go. Public. And yeah, that's it. That's all I needed. I will say having the keyboard here, I want to type on the keyboard in front of me, but it's unplugged to try and not have a janky video. All right, works. Wait, I just made a whole bunch of doubly linked list nodes and nothing changed. The exact same output I had before. Why? Because as a child class, by default, my child class looks identical to my parent class. Then afterwards, when I make changes to doubly linked list, every single change, it's going to override or replace what I had before. I'm pretty sure the next video I end up doing is step by step all the different functions I'm going to implement in a doubly linked list compared to just a linked list. One after another, I'm just going to make, so I'm going to make the stubbies here, just the blueprint for what I'm going to be changing. And then later I'm just going to fill in all of this code. So let's do that right now. The actual end, so here is doubly linked list. Where's doubly linked list node? All right, I'm going to also have a private every time. I'm going to have a linked list node. We're going to have to change this in a bit, but hopefully that won't be a big deal. The end. You'll see in a later video I'm going to change that around. I'm going to put a to-do there just to remind me later on. Magically, my past self is going to solve this problem. I'm going to have a linked list node and pointer to the endpoint. So I have a pointer to the front, pointer to the end. I already have p start. It already exists. It comes for free by being a linked list. Now I'm just going to add one other field. Okay, I'm also going to add, let's see here. So lazy. Let's add a destructor. And let's see what other functions I have in here. Okay, this operator, do I need to do anything? No, I won't need to use this. Why? Because it's actually going to call insert at front. I will probably need to redefine those and print and get end, I do believe, and yeah, take care. All right. It's going to be that essentially. It's going to be, there's going to be hardly anything in here. So let's copy that. And I'm going to then, I think I need to do insert. Insert at front is not going to change. Get start, get end. I might want to replace get end. And set start pointer. That doesn't need to change. All right, so let's just go down a little bit more. Get the end node. Okay, double linked list.h. I'm just going to plop that all in here. Okay, insert at the front. I'm going to override that one. I'm going to override this one, remove front. Okay, those are fine. Those didn't need to change. They're not going to change between my generic linked list and this new version. Why? Because the index, I'm just going to walk down my linked list and find the sixth element. It's going to be the same no matter what. I'm going from the start to the next, and the next, and the next, however many times. Same with the size. Counting the size, I've got to walk down that linked list. Doesn't matter if it's pointing in multiple directions or not. Is empty. I don't think I have to worry about that one at all. Print, I might need to change. Do I need to change it? If I wanted some special message for printing it off, I would need to change it. Let's see what this print method does. Is empty print. The list is empty. Linked list size. Okay, I won't want to replace this one. I'll fix this one up in a second. So I want to keep that in there. It's slightly different. It's going to say the doubly linked list. Blah, blah, blah. Values are this. Okay, get the start. Get the end is going to be different. And by the way, as this thing says, I don't want to know how this thing works. I don't want to know where the start or the end point is. What I'll do later on, I have a video on this already, is I'll use what's called an iterator. I'm going to say, give me an iterator, which will start pointing at the front. And then I say, hey, iterator, what's the next value? Hey, iterator, what's the next value? And the iterator, I do not know how this thing is built. The iterator just points to the starting point of it. You don't know how it's doing, what it's doing. You just know you can get the first value at the value at the start. That's it. Okay, that's get end. Great. I might want to do that slightly different. Why? Because I have the end. Okay. I'm going to need to implement all of these things. So I'm going to do the bare minimum to make sure that this thing works. And then I'm going to pause the video to make sure that it actually recorded and it's not janky. Double linked list, no, double list linked list.cpp. This thing is going to do nothing, or I can have it do a print out cout statement. Cout doubly linked list created. All right. Is that something wrong with that? I just want to double check on this. Oh, of course. What am I missing? I'm missing that universal thing that I said I did for all the other ones. I don't want that just to include the doubly linked list header. I want to include everything. So I'm going to include this catch-all thing here, L10 LL includes .h. So if I save it, suddenly that goes away. Why? Because I know I'm using the standard namespace. I include the header file that I need for doubly linked list. I include all the other header files. I'm including all the header files. All my CPP files are going to point using the same include. Okay, here's the destructor. I'm going to do a simple, I didn't need a destructor at all. I'm going to be very, very, very clear about this. I don't need a destructor. I'm not deleting, depends actually. If I wanted to delete each individual node in my doubly linked list, I'll do the same thing. I'll automatically call the parent's version of the destructor though. So if the parent's version of this was already made, I don't have to do squat. What I might want to do though is I might want to say p end is equal to null, right? If I've deleted everything, I want to set things to safe null values to know that I deleted everything. Okay. Let's do the bare minimum stuff. I'm going to have to fill in that. I'm going to fill in that. I just want to put something in there just to say that I'm going to go back to it. I will fill in that. I will fill in that. I don't need this constructor, the protected private thing. Okay. And one other thing I need to do for all of these, I got to put that DLL. I got to put this thing in the front of all my functions, just to know, hey, the functions I'm defining, it's for the doubly linked list. Okay, and return null, let's say. This thing is not doing anything at all yet. I just want to make it compile, make sure it works. It's not going to work correctly, but just make sure it works. And then I can actually, go through each one of these functions and fill in what the code does. Think through each of the parts. I know that next video is not janky, so I'm gonna stop it here, and then we'll go on to how we fill in the content for each one of these functions based off of what my parent class is already doing or can already do, and then I'll do a little bit extra afterwards just to make sure that this p end, this extra variable I have, is taken care of properly. Okay, so with that, I'm going to stop the video and I'll talk to you soon.